Okay, so I was studying Calculus 3 from Paul's Calculus notes, and I just had a brain blast, okay? So I was, so this is a function, I was learning about three-dimensional vector parametric functions, and I got to the equation on curvature, which is this, where, let me write it. Uh, this is the s is the length of the function. For example, imagine this is a function in 3D space. It's like a line because it's a parametric function. S is like the length if you like took this and straightened it out in a line, and you got this t vector, which is the tangent vector, which is basically it points in the direction it's moving. Now this is the curvature, but it's not any tangent vector. It's just the unit tangent vector, which means if it's like really long, it just gets shortened out to be 1 unit, and if it's really short, it also gets it's 1 unit basically. And I got to this part where it says this is the equation for the curvature of a curve. And I was like, but why? Why is it? And then I started thinking, this ds, this is a change in the surface, not the surface, the length of the parametric curve. So basically, after we take a small step, this would be this whole length. This would be the ds. And then before we got this tangent, and after we got this tangent. So if we put them side by side, this would be the change in tangent. But notice how, since we're using the unit tangent, they are all on the same radius. They all have the same magnitude. So the only thing that's changing is rotation. So this meaningfully is really just a measure of rotation. And this is just a measure of how far we've traveled in a short distance. So basically what it's saying is after taking a step, a small step in the curve, how different is our direction? So we got two major cases. Two major cases. We're slow, so we're moving really slowly along the curve, and we're rotating a lot, and we're moving fast, and we're not spinning, we're not rotating. So in this case, if we're moving really slow, then this would be lower, and we're rotating a lot, so the change in the tangent is greater. So then we have a higher curvature, because a higher number over a smaller number is a higher number. So we have a high curvature. And if we're going fast, that means the surface, I mean not the surface, sorry, the length is changing a lot, and the rotation isn't changing. And a higher number over a small number, we have a low curvature. Think about it like this. If we're moving like 3 miles per second, sure, but we're only spinning around, we're in a car, the car's only like turning at a really slow rate, then it's not gonna curve a lot because you're gonna move way faster than you can curve. But if you're moving at like 1 mile per century, but your car spins in like, it takes like a year to spin, it's not gonna move a lot, but it is gonna spin. It's gonna spin because it's spinning faster than it can like escape the curvature of the spin by just moving. So yeah, I figured that out. I was like pondering what it meant. So like, see, when you actually can turn, it like creates a curvature. If you can't, it creates a low curvature, but if you actually can, because you're rotating faster than you can spin, it's kind of like an orbit. If you're moving faster than you can get pulled down, you create curvature. And if you can create a curvature, you create a high curvature because you're spinning faster than you're moving. And yeah, I just had that brain blast and just wanted to put it on. I just like run downstairs to make this. Okay, bye.